has been doing video games, so I have it on mute.
This is going to be broadcast, so you might want to change your name.
Yes, and so maybe just go down to Dawn.
Okay, how do I do that? I can figure it out, but it might take a minute. I love it. Thank you.
There we go. I like it.
Awesome.
We might be able to make it a little bit longer. They just keep adding new terms to those names.
Oh, that's great. I appreciate it. Thanks.
No problem.
Right, I think this is going to be our group then.
Okay, well then I guess we can start a little bit early. So I guess just let me know when you're all ready and comfortable on that couch.
Oh, did Joe take off?
It looks like
It's starting.
All right, when Joe gets back, we should just say, okay, and that concludes the program. Thank you all.
Exactly.
I like it.
They're ready to start. I'm ready to start. I just can't see. Joe's ready.
All right, then I think we can go.
All right. Well, thank you all for joining. My name is Travis. I'm one of our program presenters for the Mount Lemmon Sky Center, and tonight I'm going to be basically showing you the sky completely virtually and completely remotely on top of Mount Lemmon. And so I'm going to go ahead and share my screen now, and hopefully this will all work correctly. Show. There we go. And share. Did that work? It looks like it worked. Did that work? It looks like it worked. Can everybody see the screen?
Yes.
Yes.
Can everybody see the screen? All right. So I am not on the mountain. As you may be able to tell from the fact that I'm wearing a short sleeve shirt. I'm down in Tucson where it's, 50, 60 degrees outside. However, on top of Mount Lemmon, this is actually a website that anybody can access right there. And this is an all sky camera on top of the mountain. And so it's just showing 180-degree field of view on top of the mountain. And you can see it's a nice 0 degrees Celsius. So we would have to wear several layers if we were up there, but the wind's not too bad. And so just giving you a little overview, on top of Mount Lemmon, we have about 10 telescopes, 2 of which you can't really see from the all sky camera because they're kind of down the road a little. But up here at the top of the image is the 60-inch universe, or 60-inch and 40-inch Catalina Sky Survey telescopes. These are looking for near Earth objects. You actually may have heard of a comet last year, right at the end of the year, called Comet Leonard. That was discovered by this telescope right here. And I'm hoping that you guys can see my cursor. Right down here, this telescope is actually operated by South Korea, which is pretty great. And then we've got our little 24-inch telescope, which had some fun times tonight. And then right there is the telescope that we're going to be using. That is the Shulman 32-inch telescope. And its dome is just about the same size as the 60-inch, and that's because we need creature comforts. We're all sitting there on chairs and actually looking through with an eyepiece. But tonight, we're going to be using our nice big camera. You can also see all the stars. This is a 60-second image, and everybody can pretty much pick out the favorite hunter in the sky. Who is that?
Orion.
Yep, there's Orion. And then you got Sirius, the dog star right there. You got the Pleiades, little tiny guy right there. Gals, sorry. And of course, here is the moon way over on the side of the sky, just about to set. And we got some little tiny clouds, but that shouldn't impede us at all. Now, if we hop way over inside the dome, this is a view inside of our telescope dome. And so there's our big old 32-inch telescope. We got our chairs kind of going around the sides. And I have a light on inside the dome so we can actually see what the telescope looks like. So for our programs, you would have your eyepiece down here on the very bottom. But right now we have the big old camera attached and ready to go. And so I think I'm going to go ahead and turn this light off. Now, if you don't stop me, I will literally just keep talking forever until your ears start bleeding. So please, by all means, ask as many questions as you want.
What's the price tag on that telescope?
Are you in the market?
Yeah, let's pretend.
Yeah, so the 32-inch telescope was about $500,000, but that's just the telescope and the mount. That doesn't include the dome, the electronics, the camera, and the comedian running it all.
So I mean, if you want to like cut the budget, you can just throw a tarp over it, right? Call it good.
I don't think so.
I mean, yeah, you might want to worry about snow just a tiny little bit, but
Yeah, I
Yeah.
don't think it works quite like that.
but in fact, telescope domes, as much as you would expect them to be watertight, aren't actually perfectly watertight. And so when we have huge snowstorms, or especially during monsoon season, we actually will put a tarp over the telescope.
I'm here and a tarp would do just fine. Thank you.
All right, so we have several different softwares that we are going to use today. This is the one that we actually use to operate the telescope. And it's pretty simple, even though it just has a bunch of numbers. We're just going to be clicking a button here, typing stuff in, hitting go, and the telescope's going to move. And then we're going to use another software over here that actually shows the whole sky and kind of where the telescope is currently pointing. And we'll be able to use this software to actually get a relatively live view through the telescope. This orange line denotes the entire sky available to us from the telescope. It obviously has hardware limits on how far it can move in one direction or the other, very far north, very far south. And of course, you have to worry about the walls as well. You obviously can't point right at the very edge of the sky.
So a question on that.
Yes.
I know with Comet Leonard, I was trying to get pictures of it and was not successful for Leonard. But did the fact that it was so low in the horizon make it difficult to see with this telescope? Or when did they find it that it was visible?
So we didn't discover it. It was actually discovered by the 60-inch on the end of the road on the very summit of the mountain.
Okay.
And it was discovered on January 4th of last year.
Okay.
And when it was discovered, it was much further away from us. It was much dimmer. It only got to its closest approach a month or two ago.
Right, December.
And so they discovered it really little tiny in the sky. And since then, it's obviously gotten much closer. And many different people have gotten fantastic images, mostly not in the US, because we're not in the best position to actually see it.
Right.
It actually looks like somebody is driving around the mountaintop right there.
I was just going to say.
And we can go back to here and see if we see any cars down here. That means that somebody is snooping around. Might be our normal public program, which actually ended about 45 minutes ago or so. So if you like what you see during this virtual star party and you're like, I wish I could put my actual eyeball up to the telescope and see these things for real, that is our main thing. That is what we generally mainly do. It's 5-hour programs where it's 2 hours before sunset, 3 hours after, there's dinner, sunset at 9,000 feet, and then you get to look through this telescope right here with your own little eyes.
Do they have lodging there? I mean, because that was the big question. That's a long drive from where we're at. It'd be really difficult to actually stay there.
Yeah, so obviously, if I'm doing the program, I will drive up the mountain, do the program, and then head back down. It's about an hour drive or so. There are, I think it's in June or July, there's actually going to be a new hotel that opens in Summerhaven, which is like maybe a 10 or 15-minute drive from the summit, just down to the little town on Mount Lemmon. And I think, if I recall correctly, and I don't quote me on this, I'm not the marketing guy, but we're going to be doing some cross promotion. So if you book the hotel, then you can book us, and then if you book with us, you'll get a discount on the hotel and that
Nice.
sort of thing. So
Okay.
you don't have to drive all the way down the mountain. All right, so let's see. You sent a small list of objects, and some of them we sadly just can't look at just because they're not in the sky. But I think if we can try to get the coordinates, we go over to search and we type in that very difficult word, moon, and we possibly may be able to get a view of the moon. What's kind of surprising is that the moon is really, really bright. And so for our camera, which is designed to take images of galaxies tens or hundreds of millions of light years away, it saturates quite quickly. And so we'll definitely go over and point at it, but I'm not promising the best view ever. So going like that, we're going to click go to, and hopefully if all works out, there you go. You can actually see the dome moving. Camera's taking, a couple images, 1 or 2 images every few seconds. See the dome's moving over there to the right-hand side, and then our telescope is going to point at it. And you can see just how low in the sky the moon is. Like we're only for the next little bit going to be able to look at it because it's way there, almost right at the limit.
Oh, wow. And it's only a crescent, but is it still, well, I'll just wait and see what it looks like when we get there.
Yes, so what we're going to do is we're going to go to camera, and we want to do binning 1 by 1. We're going to, where's the button? Oh, right. Filter wheel, let's use a different filter. Let's do, say, red, because we want to try to limit as much light as possible that we're getting from the moon because it's just so bright. And then we're going to take a really short exposure. We're going to take like 1,000th of a second or 100th of a second if it won't let us do that. So once the filter wheel is there, perfect, we're going to take a photo. This camera is a 16 megapixel camera, and it has a piezoelectric cooler on it that keeps the actual sensor to negative 30 degrees Celsius. And there you go. So if I blow this up, right here, that's the edge of the moon. And what's actually interesting is that we're not looking at the lit side of the moon. This is the dark side of the moon. These
wow.
giant bands coming off is actually the bright side of the moon, kind of the actual crescent that you see in the night sky right now. And it's so bright that it's reflecting through the telescope and making these bands going across the image. And so if I zoom in, you can see there's a nice crater right there. You can see one of the C's right here. There. And actually, I think I saw it. Yep, there's just a little random star in the background. But unfortunately, I might be able to nudge us just a little bit to try to get more of the moon in our field of view. And we'll attempt to do that. But if it's already overexposing almost exposing correctly with that side. I can only imagine when we get to the lit side.
Right.
So let's try that again. Sadly, because the camera is relatively old and it's supposed to be super sensitive, it takes a really long time to read the image out. So unlike your, okay, I went the wrong direction.
And that's the aliens, right?
I'm not allowed to disclose that information.
Darn. I'll just tell everybody it is. It'll be okay.
Look at that. So I literally can't even move the telescope to a position to actually point at it because it's so low on the sky.
Oh, wow.
So
Yeah,
instead,
I did notice it was just, I mean, a very slim crescent, and it's just rising.
it's setting.
Oh, excuse me. Yes,
If it was rising, we would just wait a little bit.
exactly.
And actually, the telescope is pointing so low that I actually need to move it back up to a normal position in the sky. You can see that's actually the moonlight right there coming into the telescope dome. So instead, now that we're pointing back up a little bit, let's go to the only planet that I can show you, unfortunately. It's the only one in the sky still. We are going to go to the 7th planet in our solar system. What would that be?
So Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus.
There we go. So we are going to go to the planet Uranus. Or if you are still in elementary school, Uranus.
You just said Uranus.
Or if you want to go from the original Greek, it would be Uranus with a rolling R, which is honestly just so much cooler.
Uranus. It's great.
So while you're repositioning, I'm going to talk to some of my people in chat. So I see
Yeah.
MZ. Thanks for joining. I have my friend Pause Reset from the UK. Venomous, where are you watching from? I don't recognize the name, but welcome.
Yeah, and if anybody from your chat has questions, they're more than welcome to send it to your chat and then to you, and then you can read it to me, and then I'll answer it.
Perfect. That's what I had set up. I've got one of my mods that's watching that chat in case there was, but nothing yet.
All right. So we're now going to be trying to do a live view method that will just continually take 1 second exposures. And hopefully 1 second is little enough. And you can actually see right here. So this is our whole camera field of view. Not a lot of stars in this area of the sky, but right here is the planet Uranus. And even when I go all the way down and try to get to the dimmest, it is still too bright for our camera, even after 1 second. But what's really cool is that you can actually see right here, this little trapezoid of 4 stars. Those are not stars. Those are 4 of Uranus's largest moons. So if I come over to, I'll actually do it on my personal computer so it's not getting in the way. I can tell you that 2 of them are Oberon and Titania, and then the other 2 should be Ariel and Umbriel, but I'm going to check that right now. Does anybody recognize those names?
Well, Titanus sounds familiar.
Not Titanus, Titania.
Oh, Titania. Okay.
Yeah, no, Titania.
Husband recognizes one of the names. He's pretty into this too.
All right, and what is it from?
I recognize Titania. It was just for one of those memories I remember from high school.
All right, but where does the name come from?
Oh, I have no idea.
The Titans from Greek mythology? Possibly?
Not from Greek mythology. In fact, it's not from mythology at all.
Wow.
So Oberon and Titania are the king
Astronomer.
and queen of the fairies from A Midsummer's Night Dream in Shakespeare.
Oh, man.
And so, unlike all the other planets in our solar system, besides Earth, because our moon is just called Moon, the moons of all the other planets are named from either Greek or Roman mythology of characters that interacted with the god. So you have Zeus or Jupiter, and so all of Jupiter's moons are named from Greek or Roman mythology of characters who interacted with Jupiter or Zeus. Uranus, however, is actually the name of the Greek primordial titan of the sky. He was the father of Kronos, who was the father of Zeus. And so for some reason, they decided instead of trying to name characters from there, which would actually be very similar to all the names of characters of Jupiter or Saturn, Kronos and Zeus, they went with Shakespeare. And so you have the names Ariel, Umbriel, Oberon, Titania, Miranda, Juliet, and there's about 35 moons orbiting Uranus. Let me check if we've discovered any in the last couple months. Okay, 27 moons are currently known to orbit Uranus.
Now, size-wise, Uranus compared to the other planets, where does it fall as far as size?
It'll be the fourth largest. So there's Jupiter, Saturn, and then much smaller Neptune, and then a little bit tinier Uranus, and then a fourth the size is Earth, Venus, and then you go even smaller. So Uranus is what is called an ice giant. So it is one of the gas giants, but because it's even further out from the sun, it has a lot more ice in its kind of upper layers, and so it's called an ice giant.
Oh.
Now that we've all seen this wonderful blob just kind of sit here doing absolutely nothing. Oh, there we go. You might even be able to see another moon. And actually, that is not one of them. There should be a moon right about here in the field. But Uranus is just too darn bright. All right. Tried to look there. Okay. So Uranus is only about 2 light hours away. So quite close in terms of, huge distances. The sun is about 8.5 light minutes away from Earth. The sun is about, or the moon is about 1.2 light seconds away. We're now going to go just a little bit farther. And apparently, just a little bit farther means that I actually have to go much, much farther, because the thing that I wanted to point out is just a little bit too low in the sky. So we're going to go even farther away.
So I was looking at some of the pictures that were recorded on the page.
Mhm.
There was one that just had a ton of galaxies that looked really interesting. I know
Okay.
I know I had put the Andromeda galaxy on the list, but obviously I can see it's right there.
Yeah, it's right there. Actually, it's right here. So it's below our horizon, sadly.
Okay.
So actually, now that I think about it, once we go to this guy, we might be able to hit M33, which is a nice galaxy. And we can look at different things with the camera than we can with our eyes, because the camera can be a heck of a lot more sensitive. Way over to the other side of the sky. And so let's do our live stack. We're actually going to go much higher, and let's do something like 15 seconds. So we're now going to be looking at M82, better known as the Cigar Galaxy. I want you to guess what it might look like.
Well, I looked at some of the other pictures, so I think I have a good clue.
There we go. There he is. And again, this is basically a live feed from the camera right now up on top of Mount Lemmon.
So now,
This is-
why is this one all seems to be black and white? Does it have any colors that it picks up?
Yeah, so our camera is a monochrome camera. And so your cameras that you say have at home or your webcam, their color, because each individual pixel actually has a little filter on it, red, blue, or green. And it's in a pattern called a Bayer pattern, Bayer. And then there's some software that takes all those pixels and then kind of smushes it and merges it together to make a colored image for where each pixel is red, blue, green. And you get a color from that. What that means, though, is that because each pixel has an individual filter, you'll go red, blue, green, red, blue, green, you're only about a third, or actually a fourth, the resolution, because each filter can only do one color.
Okay.
Our camera is monochrome, and so all the light comes straight through and hits every single pixel. And so you might have seen there's a little thing right here called filter, and that's because we have a filter wheel on the monochrome's camera that we can switch through, so we can get an image in red, get an image in green, get an image in blue, and then through software put those together, kind of like how our brain does that processing with the signals coming from our eyes. And that's how we make our super pretty color pictures.
Okay. So essentially, I could take some of these images and I could actually do that processing on some of the software that I have that I use for my photography.
Yeah, I mean, some of the best astrophotographers in the world, they'll use one software to actually calibrate all the images and actually get them into a easy format like a TIFF or something.
Mm-hmm.
And then they'll use Photoshop for the rest of their processing.
Right. Okay.
And so, yes, you absolutely, maybe not from the live stream,
Yeah.
but, you could take this image and you could produce something like, we go to everybody's favorite website, skycenter.arizona.edu. We can type in M82, and if I actually typed it in correctly, this is what that galaxy looks like under much longer exposures.
Right.
In this case, it is 41 hours
Oh man.
worth of data. And that's because it's not only red, blue, and green, but this image is, you can consider enhanced with hydrogen alpha, basically a filter that it only lets the light in that comes from ionized hydrogen gas. And that's why you have this really, really nice pink kind of exploding out from the center. That's due to properties about this specific galaxy. But in normal images of this galaxy, you can't see that pink nearly as well,
Right.
because they're not enhanced with that hydrogen alpha.
Can you talk about that, those pink clouds above and underneath it?
Yeah, these guys right here.
Yeah.
So in the case of this galaxy, it's called a starburst galaxy. This galaxy has massive star formation. We're talking between 50 and 100 times more stars are being born in this galaxy compared to our own Milky Way. What that also means is that there's a lot of star death. And so actually back in, I want to say, I think it was 2013 or 2014, a supernova went off in this galaxy that we could observe. You could actually see it through the eyepiece. And because there's so many stars that are dying and exploding outwards, you get these plumes of hydrogen gas coming out from the galaxy, because the density of the stars are higher in the center. That's why you get these kind of pink clouds kind of coming out.
I was told, or I forget where I picked it up from, that on those newer galaxies, the supermassive black hole in the middle kind of picked up all that extra material as all that was going on, and it kind of kept storing it up, and it hit a critical mass. And they said that out of the top and the bottom, it would explode all that excess. Like once it hit that critical point, it would explode out. Just these huge jets for hundreds of light years that would like pretty much vaporize anything that it touched.
Yeah, thousands of light years actually. And in fact, let's see if oh, too bad. M87 is one of those galaxies with a stupidly supermassive black hole. We're talking 1 to 2 billion times the mass of our sun. And just because I can plug the images on our website, if you go to M87, this is that galaxy. Doesn't look super impressive until we zoom in, and you can actually see the jet coming out from the center of the galaxy from that supermassive black hole.
Oh, wow.
And this one,
Well, hey, I'll bring up, we're getting some comments from chat that people think this looks very beautiful and breathtaking, pretty cool. So,
would they say that it's pretty stellar?
okay, no, they didn't say that.
I see what you did there.
And then I got a whoa. Oh, so yes, it does look really impressive.
Yeah,
I
and
do,
again,
I do like seeing the comparison between what you see with the monochrome and then seeing some of those photos. It does really, it helps us to visualize what's going on a little bit more. So very
yeah,
helpful.
and another thing is that these images, they're not only much longer exposure, but then even what our eye sees compared to what the camera sees is pretty significant. If we were to look visually through the telescope at the Cigar Galaxy on a nice dark night like this, you absolutely can see the galaxy, and it's awesome that you can, but you can just barely see that kind of dustiness of it. While on a camera, it's just right there. You can see it super easily.
Now, the camera pictures that you have on the site,
Mhm.
what type of lenses were they using to be able to capture those, or do they actually get hooked up to the telescopes?
So
How does
all the
that work?
all the pictures on our website are from our cameras that are on our telescopes.
Okay.
And in the case of that one that I just showed you, change this to 60 seconds real quick. That image was taken through the 32-inch telescope with the camera that we have on it right now. But
Oh.
instead of taking a few seconds and just trying to show you that kind of live, it's taking hours and hours worth of exposure
Okay.
and then going through a very lengthy process to actually produce those nice, pretty, colorful images.
So now, a question: when you do the longer program, do you go through any of that photography side of things? I'm asking for personal reasons, since I like
Yeah.
the photography side, and maybe I will make the trek down there.
I mean, please do. I think it's definitely worth it. If people ask questions, we generally will give an answer, kind of like what I've been giving right now on how we take our images. But because it takes so long to take these images, we don't put the camera on and try to take pictures and show them to everyone during the program, because it would just take far too long. But a great segue to one of the other things that the Sky Center offers, which is called an astronomer night, where it's you and up to 3 other people, and you basically buy out the rest of the night. You do the normal program, and then you have me or one of our other presenters as kind of your telescope lackey for the entire night, and you can look at whatever you want through the telescope. You can look visually, we can put a camera on, we can put your camera on, and it's just whatever you want to do with the telescope.
Right
it's basically
there.
yours for the night.
I'm probably gonna look into that, because if I can bring my cameras down and see what I could do with some of my cameras, that'd be so much fun.
If I show you, does everybody know the Pleiades, the 7 sisters? So this picture was taken with our telescopes up on the mountain, but the camera, it's with the DSLR.
Right.
And so you can get these kinds of images with a nice, fancy, newer camera. I mean, this was with a Mark II, so this was quite
It's an older one.
Yeah. And I took this photo.
Oh, nice shot.
Thank you.
It's gorgeous.
They're
Hey.
gorgeous.
So are you guys hiring?
Are we hiring? Yes, we are
Yeah.
always hiring. Honestly.
Are you trying to leave me, Drew?
Yes, I am.
I thought we were a team.
Well, there's an I in team.
There is not, but I could not ever be mad at you for going to this.
Oh,
Let
and
me get my foot in the door and I'll bring you with me. How's that?
I
You know
am
that's
not
a move.
smart.
You're gonna have to go down to Tucson to be able to do that.
That's okay.
Oh, I left Tucson and will never go back. So I have family members that will help you get settled in.
Oh, that's what you'll have to do, and you have to come home on the weekend.
Yes.
Like what I had to do at Blizzard.
Yep, there you go.
Oh, and I'll
All
do
right.
a quick shout out. I got a note from Chris, my trainer that I ride with in Scottsdale, is also watching. So, a lot of people that probably aren't in chat. So thanks for joining.
Yes, thank you. So what we're looking at right now is actually right next to the cigar galaxy in the sky. It's called M81 or Bode's galaxy. Both of these galaxies are about 12 million light years away from us. So the light that we're capturing right now, it left when orangutans were the new cool thing. Like orangutans had just split from the other great apes to be their own independent species who had red hair about 12 million years ago.
Wow.
This is what's called a grand design spiral galaxy. And as you can see, it is a nice, very pretty spiral galaxy. We can even zoom in here towards the middle. You can see these nice dust lanes going around all around the outside. If we zoom all the way out and kind of overscale, you can see it's quite big.
So, how do you distinguish which ones would be planets within the galaxy versus some of the stars that are just shining through?
So as of right now, there's only one planet that we've seen outside of our own galaxy, and it was a microlensing event, which is super rare and doesn't happen again. So it's kind of a fleeting, you see it once and you're like, well, that was great. So what you're seeing, every single star that you see in this image, every single one of these individual point sources is a star within our own galaxy, the Milky Way. And then way off in the distance is this galaxy. So it's kind of like standing in the middle of a city, seeing all the streetlights around you, and then way off in the distance, you're seeing the glow of another city.
Okay.
You can't see the individual streetlights of that other city, but you can see the collective glow of the whole city in total. So even like right here, if I'm zooming in and I'm seeing each of these dots, each one of these is a star in our own galaxy. And then way off in the distance is just barely kind of the fuzz of the other streetlights in that galaxy.
Okay. So when you amplified that, you could see that there was like mini star trails. What would that be? Yeah.
Like these little, all the stars kind of doing this little shift.
No, if you go over to like the, and I know you can't see my mouse when I'm doing it, but you see what I would call like a timing issue that if I max out my speed at 30 seconds, you start to see star trails when you photograph.
Oh, I see what you mean.
Okay.
Yeah, so the little, here we go. Kind of all these stars having this little shift.
Yes, a little bit of elongation.
Yeah, so that's because the telescope is moving with the sky. So it's tracking the sky, but it's not perfect. As it moves through the sky, there's refraction, there's little mechanical errors in the telescope mount itself. And so you'll have little bits of drift as the telescope is following the sky. And as we take more and more images, it becomes more apparent. And so this is literally just the slight tracking errors of this camera and this telescope. And so you can see this is 5 minutes. So over the course of 5 minutes, a star has moved just that little bit through the field of view of the telescope. Now, if we actually, so if I did say 10 seconds, let's start our 10-second exposures. What I'm going to do is while it's taking images, I'm going to turn off the tracking of the telescope.
Oh, okay.
So we're going to take one image right here. There's the galaxy in just 10 seconds. And I'm now going to click that button. And this next image, we'll see a little bit of a star streak. And then the next one after that is just going to be awful.
Yeah.
So there you go. There's a tiny little star streak. And that's because I turned off the tracking with like a couple seconds left. This next image. Oh, it says 1 frame rejected. Apparently did not like actually that image for some reason. That's hilarious. I didn't realize that it would do that. So apparently it doesn't even want to show us the star streaks, which is kind of funny. Let's see if I can show you guys M33. Awesome, we can. There you go. There is 10 seconds. And you can see the galaxy, it was in the center, is now over here.
Right. Definitely want that tracking on.
Yes, very much so. And this is actually kind of fun.
Yeah, what's up with that?
So I tell the telescope to move to a new object. And so the telescope went, okay, and kind of got itself into gear and moved to, it is now moving across the sky. And so this little wobble is from it doing that. That's actually kind of fun. So if we're looking here in the sky, we're going to be looking right around in here. I go M33. Oh, right there, right on the very edge of the sky.
So when it's that close, do you think it will be?
What do you mean?
Oh, you said, well, it's right on the edge of the field of view.
Oh yeah, we absolutely should see it. It's more of that it's right on the edge of the limits of the telescope because it's starting to set.
Right.
And so it's just barely in the where we can actually point at it. So we will be able to see it. M33 is the second closest galaxy to the Milky Way, like nice big galaxy. There's Andromeda, which is 2.5 million light years away. And then there's M33, the Triangulum galaxy, which is about 2.7 million light years away. And there we are. So if I boost this up, you can see it's a kind of face-on spiral galaxy. So you can see the spiral and it's kind of pointing at us like this rather than kind of like that or kind of on its side. And it's actually a very small galaxy. And even though it's really close, it doesn't have really nice, impressive spiral structures. It just has kind of these very generic spiral arms. But because it's so close, we can actually see, looking right here, right there, and an even better one that I can't quite see because the camera's there. But those little smudges, this smudge right here, this is actually a nebula within this galaxy. So this galaxy is close enough that we can effectively see kind of the parks of this city. You know, if each star is a streetlight, a nebula could be considered like a school or a park or a hospital, some larger thing that you can see from afar because they're quite big.
And this was which one again? You said M30?
33.
33.
All right, I'm going to bring up on my screen a little list of things.
Can you find can you see the TRAPPIST system?
You know, why don't we find out? We're not going to be able to see any like detail. Okay, so that software doesn't have it. So we're going to do the super fun thing and literally just Google it.
Google knows all.
No, it is not up in the sky, unfortunately, right now. The 23 is, yeah, so it is slightly below the horizon, unfortunately.
What about a Muamua?
I wouldn't even know how to get those coordinates.
Like,
But
do
I
we still
could-
have? Oh, go ahead. Sorry.
No, please go ahead.
Do we still have eyes on it? Like, do we have a location for it?
I'm sure. Let's see. Anybody know how to spell Oumuamua?
What?
Oh, sorry, what?
Muamua?
Exosolar asteroid. There we go.
Wow.
Yeah, yeah, that's how you pronounce it. So if I did,
I'm not even going to try to pronounce that. Oh, we had someone in chat who also had that correct name. So kudos to chat. I've got a lot of people in chat some people in chat who are really into this as well.
ooh, I know what we can do. If we want to see something that is in our solar system that is just tiny and moving, I'm hoping that I can get this. The James Webb Space Telescope.
Oh,
There you go. Yep.
what and even the International Space Station, is it visible right now?
It is not visible, and if I try to take a picture of it, it moves through the entire field of view of the camera in a quarter of a second.
Yeah, I was gonna say.
Exactly. I had a friend of mine who photographed the International Space Station in front of the sun and had to perfectly time when it passed there, just for that reason. So yes.
Yep.
Rather difficult.
That would make an amazing picture, though.
Haha, yes, we can definitely look at this. Okay. So we're going to put in the coordinates 07, 20, 04.8. Everybody writing this down? 9.
Yeah, because it's gravitationally locked there. That's the
It's
Lagrange point.
It's recorded.
Yeah, so we're looking at the coordinates right here. It's in Canis Minor. So here's the entire sky. Here's Sirius. So we're looking just around this area of the sky. Oh, sorry, just around this area of the sky. In fact, if I go to my charts and I do constellation labels, there's Canis Minor. If I did boundaries, it's going to be in this box right here.
Can you turn the labels back on?
Oh, yes.
Just so that
There you go.
I get a little bit more on the video. I wanted to see.
Yep, there we go.
Okay.
So if I zoom in here, oh, too many stars. But this very dim blue line that you can just barely see, that is the area of the constellation of Canis Minor. Constellations are not the shapes that you draw. Instead, they are the boundaries of a given area on the sky, kind of like the borders of a state.
Okay.
So that's why we say something is in a constellation.
Right. So it's kind of like how we track the location of stars. General.
Yes.
We get the general mapping of where majority of the meteors originate from.
Yes, and that's because as the Earth orbits the sun, a meteor shower is caused when the Earth, as it's orbiting the sun, literally moves through kind of the tail of a comet or a very dirty asteroid. And so it'll move through that and basically be bombarded in one direction. All right, so here is the field of view in the sky where the James Webb should be. And so we're going to be looking here in the middle for something that is moving. Just slightly.
That is what?
That is moving.
Okay.
Maybe I can boost this. Okay, start counting, everyone. This is quite a dense star field. I'm not seeing anything. If it is fully parked at the Lagrange point, it may not be moving compared to us by any significant amount. So it's probably in here. It's just I can't tell you that it's this star versus a different star.
Would it appear as a dark object, or is it illuminated in some way?
It's being illuminated by the sun, and so
Okay,
it
so the same
absolutely,
as other things.
yeah, it would definitely be lit. It all just depends on which dot it is, and I'm not sadly seeing any that are prominently moving. Oh, that is way too much. Oh God. Some nice bright stars, though, I have to say. Well, I say bright, these aren't bright at all, but in 15 seconds, you can see pretty darn dim. But there you go. You are somewhere looking at James Webb right now.
Hooray!
Somewhere. If we really want to get if you want to get a man-made object, we can attempt to point at a DirecTV satellite. How's that?
Okay.
Or we can go to something out in space.
Well, one
Like-
thing, I'd like to see something close, just to see how it appears.
-05, 15, 21. And I'm actually going to change that to 51.
So if I wanted to see an object on the moon, a man-made object like a booster or something,
Okay,
how big of a telescope do I need?
very. So
Like yours?
much bigger.
Oh, really?
Yeah, so even Hubble, which is completely outside of our atmosphere, 2.5 meters in diameter, its highest resolution camera, a single pixel on that sensor would be a football field on the moon.
Oh, wow.
That's how far away the moon is.
That hurts my soul.
Oh,
However, and I highly recommend Googling this right now, there is a satellite in orbit around the moon called the Lunar Reconnaissance Orbiter, and it has actually made a survey of the entire surface of the moon in the same detail as like Google Earth, about 1 pixel per square foot.
so,
And on that, you can actually find all of the Apollo landing positions.
so it's the Lunar Reconnaissance
Orbiter.
Orbiter? Okay, I found it.
And my favorite is the Apollo 17 landing site, because you can not only see the descent stage, you can also see their footpaths and where they drove around and where they illegally parked their car.
Oh, and
Illegally parked.
abandoned it, no less.
Yeah,
Oh, wow. That is really incredible. All right, so I'll have
So-
to go dig into that afterwards.
So what about this moon ringing phenomena when they dropped the stage booster on there and they NASA said that the moon was ringing like a bell?
I would need to look that up in more detail. What I would guess is that when they hit the moon with something very big moving very, very fast, they basically detected a tiny earthquake, or moonquake, I guess would be the technical term. Aha, there are.
Oh, there it is. Okay.
So right there, and let's wait for the next image to download. There we go. That little line, that is a DirecTV satellite. That is DirecTV number 11.
Oh, wow.
And it is moving through the field that much in a 5-second exposure. And then it takes that long to download. is that should be DirecTV 11. There should be a second one actually following it, which is DirecTV 14. So let's wait a few more moments. But if I was to turn off the tracking of the telescope, there we go.
Oh, okay.
So there's the other one.
So while we're looking at this, I wanted to call out to my sister and brother-in-law. I know you've been really quiet there. Was there anything specific that you wanted to see?
You guys?
We just wanted to see planets.
Oh, I know. Unfortunately, only Uranus was available.
All right. I can't do a planet. Could I do a planetary nebula?
Yes. Oh, that would be incredible.
Okay, apparently not that planetary nebula. It's always the one that I want to click on. Let's do, there we go. Let's do NGC 1535. How does that sound?
Well, I'm not
Great.
familiar with it, so I'll trust you.
So NGC 1535 is better known as Cleopatra's Eye, is the name of the nebula. So planetary nebulas, they're named that because when they were originally discovered, they were very small, very round, and had a slight blue color to them. And so they looked very similar to Uranus or Neptune through a small telescope. But we knew they weren't planets because they didn't move around through the sky. So we called them planetary nebulas. And this is an example of one. And we're actually going to want to do a pretty darn short exposure because these are relatively bright and they're quite small as well. So taking our 10-second exposure and waiting the long time for this darn camera to read out. And this nebula, yeah, it's just about 6,000 light years away. So this light left 6,000 years ago. And so if I brighten the image, you can see just how tiny it is in the whole camera. If we zoom in, you can see it does have that glow, that ring, but it also has an inner ring. And if I bring the brightness down even more, you can actually see it's a circle and then a star right there in the center. So not a planet, but a planetary nebula. Does that count out counterbalance?
Cool.
So that little guy right there in the center, that is a white dwarf. That is an object about the mass of the sun, but only the size of Earth. So these things are incredibly dense. About one sugar cube would weigh just about 2 tons, give or take a sugar cube.
Wow.
Ah, there we go. Okay. This is actually a great time to do a bunch of nebulas. So I'm going to give you a few kind of rapid fire. 2359.
Can you do the pillars of creation?
Unfortunately, that is not in the sky right now. But I can show you a nebula that's even better than the pillars of creation.
What?
But I'm going to
That
save
exists?
That doesn't exist? Okay, cool.
Oh, no, I'm asking, does a cooler one exist?
Oh yeah. I mean, the pillars of creation, they're nice, but you know, visually through the telescope, you can barely see them visually. There are several nebulas that are much brighter.
So we'll definitely take your recommendations on the nebulas.
Let's go pretty long. Let's do a 30-second exposure. We're now going to be looking at NGC 2359. Fantastic name. It's better known as Thor's helmet.
Ooh, okay.
So this is also a planetary nebula, but it's had some crazy things going on with it. It might, now that I'm trying to think about it, but it's called Thor's helmet because it literally looks like like a Viking helmet with the horns and everything, which technically Viking helmets didn't have, but that's besides the point.
Getting them Ragnarok vibes.
Oh, there you go.
There you go. So there's the helmet, and then you got those two big old horns coming out. And if I zoom in, you can see there's this really fantastic kind of filament kind of structure to this. And it even comes all the way down here. If we go to everybody's favorite website.
Shameless plug.
Oh yeah, shameless plug. 2359, Thor's helmet. This is what it looks like in an even longer exposure.
Wow.
This is 20 hours through the telescope. Ooh.
Yikes. You know, I like that name, but you know what that reminds me of?
What?
Golden Snitch.
Okay,
You're right. It does. I could see that.
quick, grab it, Harry. Put it in your mouth. It's definitely sanitary. All right, I actually don't have the coordinates of this next one, so I'm going to have a fun time typing it in manually. See if I can bring up the coordinates so I can.
So just a quick comment from chat. They could totally see the helmet once we showed the color.
Oh yeah,
Yes.
yeah. The color definitely helps. And again, I'm trying to show you an image as quickly as I can, so we can't do 5 minutes or anything like that. We now are about 2 minutes, and you can definitely see that shape much better now.
Oh, it is much more distinct.
05, 40, 59, negative 02, 27, 30. All right, we're gonna move in the sky. So we were pointing right here, just in Canis Major. There's where the DirecTV satellite is. Gotta click off to the side. And we're now going to be moving right there, just below the belt of Orion. Actually, just below the star named Alnitak. And if we do our 30 seconds again, click the button. The fun, exciting name for this one is called Barnard 33. It is a dark nebula. So this is a nebula that isn't really emitting light on its own, but it's being backlit by another nebula or some stars. And so you can actually see it in profile, kind of like a silhouette. I'm sure all of you will recognize it as the picture comes in. And whoever shouts out the name first wins a gold star. Okay, we have aimed incorrectly. That's hilarious. So let's try that again. This is why you don't get your coordinates from Google. Well, I guess you're going to have to see what I was trying to sneakily show you. Pointing at the Horsehead. That doesn't seem right. Maybe it is. Okay. There we go. Now it's updated. That was being very strange. 4206.8, and then these objects we generally don't show for the public program, so there's not a quick, easy way to type in their coordinates. The Horsehead Nebula is an object that personally I have never seen through the telescope visually, because it's such a dim object and the contrasting color is red. And the human eye is not good at detecting red at all. Cameras, however, are much better at detecting red. And so you should be able to do, let's do a 60-second exposure. And now we have the fun time of waiting.
Was there anything you guys wanted to see, Nick, Don?
No, I'm good.
I love seeing the nebulas. Definitely.
Yeah, I think you
So
guys
cool.
have covered everything. It's been amazing.
There was one thing that I was curious on that I had
Yes.
on the list while we're waiting, and that was looking at Betelgeuse in the constellation Orion because they said it was
Yes.
a dying star. And,
Yes.
okay.
Is it
And,
actually dying or is it going through a dim phase?
it did go through a dim phase a year or two ago. It literally dropped in brightness by 70%, 80%. It was significant.
Yeah, I remember that.
But it is a star. It's a super red giant star, and it is towards the end of its life. And okay, so we can see a nebula right here. It seems that my coordinate system is very poor right now, and I don't understand why. So here,
So
what
what is
I'll,
the thing towards the bottom of the screen where it just looks like a black blob? Is that just noise? Or
so yeah, this guy right here,
yes.
this donut, that is a dust donut. So that is literally a mote of dust on the camera filter,
Oh, okay.
and it's literally making a shadow onto the camera sensor.
Okay. They need to clean their lenses.
I need to clean it. Now, considering that there is only one, that's really good.
Yeah,
Like,
no, I was gonna say if there's only one that we've seen like that, that would be. I struggle with that. My lens is clean, especially photographing outside.
all right, I can definitely show you Betelgeuse or Beetlejuice. Just don't say it 3 times fast. Michael Keaton will jump out of the computer screen. And if I recall correctly, there's a nice star cluster that has a pretty fantastic, little nebula next to the cluster. But before that, we're going to do Beetlejuice. Now, I'm only doing a 1-second exposure, and that's because Beetlejuice is very bright. So there's Beetlejuice right there. Huge diffraction spikes going through the image. You know, if I brighten this up so that you can see the whole image, you can see those spikes go all the way across the sky. And this star is what's called a super red giant star. So this star is about 1,000 times the diameter of our own sun. This is a massive, massive star. And it truly is at the end of its life. This star will go supernova in the next 100,000 years.
So tomorrow, right?
Yeah, right.
I mean, it could go supernova right now. Darn it.
If we just happen to be on the telescope when that happened, that would be pretty.
Yeah,
Yeah, you
if
can
that
see it.
happened, the image would just look like that.
Right.
I heard somewhere that if it goes supernova during the day, you'll be able to see it in the day sky.
If it goes supernova, or when it goes supernova, it will be as bright as a full moon for 3 months.
Oh, that would be.
So it's not that you'll see like a bang and then it'll be gone. It'll go bang and it'll be there for 3 months in the sky, day or night.
Have we ever witnessed something like that? That we could. How do we know that?
Funny you should ask. We're going to now go to one of these events. So there is a nebula. It is called M1. This is the first object in Charles Messier's catalogs of things that are not a comet, because he didn't like comet, or he was trying to find comets, and he kept finding things that weren't comets. So he made a list of things that are not comets, so he didn't have to look at them again. Astronomers back in the 1700s, that's basically what they did. And this is a supernova remnant. So this is what happens when a star dies, when a massive star dies. It will go supernova. And so Beetlejuice will do this exact same thing. And this one, we actually witnessed the creation. We actually witnessed the supernova that made this nebula. It happened in 1054 on July 4th. It was a Tuesday. And on that date, a new guest star appeared in the sky. And that guest star was about half, kind of about the same brightness of a half moon. And it shone that bright for about 2 months or so. And this is that nebula.
That is so cool.
Yeah, it is quite a nice nebula. And so you can see this kind of filamentary, like almost like tendrils. If I can dim that, oops, that. So all of these tendrils and stuff, that is basically the guts of the star that just got violently shot out into space. And this little guy right here, that is the leftover core of the star. That's called a neutron star. That is an object between 1 and 3 times the mass of the sun, but not the size of Earth. It's the size of Manhattan.
But what, does it have a similar density to what you said for the other?
Much higher.
Much higher?
A single sugar cube would weigh, if I'm remembering correctly, about the same as like 3 oil tankers.
Wow. Okay.
Or some ridiculous number like that. I actually should look that up again to get the correct number. But these things are incredibly dense, and they also spin super fast.
Do they grow?
Say again?
Do they grow?
No, if anything, they slightly shrink. Not by a lot, but they're so dense that they just kind of sit there. It's just super, super, super hot, spinning incredibly rapidly.
If I was like on the Starship Enterprise, I wouldn't want to drive through this. You'd want to skirt around it then.
Through the nebula itself, you would be fine. Nebula densities are quite low.
Okay.
You might not even be able to detect that you're necessarily in a nebula, depending on its size. You would not want to get close to the neutron star.
Okay, that makes sense.
Yeah, the gravity of neutron stars is ridiculous. The electromagnetic fields are insane. They emit X-rays and gamma rays. They are intense objects.
Can you say something about strange matter?
It's a little strange.
Can you go into a little more detail?
So there's several different types of matter, if I'm remembering correctly. So we got trying to think through the words. You got electron degeneracy matter, which is what white dwarfs are made out of. This is material that is been compressed to the point where only the forces between electrons is actually keeping it from imploding more. If you get more mass, it'll shrink even more, and that's called neutron degenerate matter. That's where literally everything has been fused into neutrons, and it's now literally the repelling forces of just neutron particles keeping it from imploding. If you add even more matter, you will become a black hole. You'll have an area around you that light cannot escape. And if I'm recalling the description correctly, that strange matter would be where it is the force between strange quarks that are keeping it from collapsing even more. But we don't know if strange matter even exists, because its density would be so high that it would have an event horizon. It would look identical to a true singularity. It would look just like a black hole. If you had a true black hole that's an actual singularity where the density is infinite, and you had a strange star made out of strange matter, they would look the same from the outside.
So speaking of black holes and matter, is there a black hole that we can?
By definition, no,
Okay.
because they're black holes.
Right.
You literally can't see them. The
But don't
closest
they
thing
have
that
the event horizons like what they photographed just recently? I think it was lady.
Yeah, that was like 4 years ago.
Yeah.
recently before the pandemic, which was like 2 days ago, right?
Yes, I know. It does. It seems like everything that I remember was right before we all went into lockdown.
Yeah, it was 2 days ago, and also 400 years ago. This is insane. So yeah, we did image the shadow of a black hole and its accretion disk, so material that is orbiting and then falling into a black hole. But that was done not only in radio wavelengths, so we couldn't use our camera to take those images, but it was taken with a telescope called the Event Horizon Telescope. And this was a series of radio telescopes all over the world that combined their data together to make the equivalent resolution of being able to see a mini donut on the moon.
Ooh.
That's the resolution that they
Wow.
needed in order to actually observe the event horizon.
Okay. So definitely can't do that with this.
Correct. It's a little past our spending budget. But this is probably the closest thing that I can show to a black hole is a neutron star.
Okay.
Because they are the thing right before a thing would become a black hole, and they're extremely energetic. You may be able to even see that there's almost like a spiral or kind of a circle, and that's because this neutron star is spinning about 30 times a second. And again, this is an object more than the mass of the sun, the size of the island of Manhattan, spinning 30 times a second. And so all the material around it's being basically bombarded by its magnetic field and being irradiated by its sheer heat and making this. The whole reason this entire nebula is glowing is because it's still energized both by that neutron star and by the leftover heat of the supernova.
So just for comparison's sake, what is the size of this nebula? I mean, how, like, if you were to measure the distance across it?
Here, let me get my my ruler out really quick, and if I can look it up just really quick. Generally, we do have a rough distance. There we go. So its radius. So let's convert that really quick. So from this end to this end is about 11 light years.
Oh, wow.
And it's only 1,000 years old, roughly. So in 1,000 years, this object has gone from the size of a star to 11 light years in diameter.
Okay.
This thing is actually still expanding at about, what was it? It's about 11,000 times the speed of sound, just several percent the speed of light. There's
That is bonkers.
Oh, it is. And so, because we got on this one because of the whole supernova phenomenon, are there recorded sightings of this being in the sky when this happens?
Yes.
Okay.
So we do Messier 1, and we go to everybody's most trustworthy page. History.
You said it was 11 light years across the distance in relation to the Milky Way. What is the Milky Way?
100,000
Oh,
light years across.
okay. So quite small.
Yes. So on July 4th, 1054, remained visible until April
Oh, for 2 years.
1056. Yeah, this was visible in the night sky. During the day, it was a couple months.
Okay.
But I'm hoping, well, we have this dumb filter on here. I was really hoping they would have the. Well, there you go. There's a picture.
Artist rendering.
Oh, well, here, if I just do this, there is a petroglyph. Petroglyph.
Thought it was a Y, but
Perfect. Here we go.
there.
Oh, yeah, wonderful image. Thank you, Google. There is a petroglyph in Chaco Canyon in New Mexico. And you can see there's the crescent moon, and there's a nice bright star. And there's a couple other things around it that we've been able to look at. But we've actually, I don't think we used carbon dating, but we used some radiometric dating method. And this is about 1,000 years old. And so this is literally a picture of that supernova that was drawn on this rock by Native Americans in New Mexico
Wow.
in 1954, about 1,000 years ago.
I bet there's others too, because I did a petroglyph walk in the White Tank Mountains by us, and there were some that had that same star pattern, and the age is about the same. So.
Yeah, we've seen supernovas in other galaxies all the time, but in our Milky Way, well, that list didn't actually give it. We've only seen maybe a dozen or two. And that's because we are within the galaxy, so we can't really see through it super well. We're actually overdue for a supernova to occur in our galaxy.
How much of our view is blocked by Sagittarius A?
By Sagittarius A star, the supermassive black hole in the center of our galaxy,
Yeah,
barely any. And that's because it is, although it's supermassive, it's still very small compared to the galaxy. You know, our galaxy is 100,000 light years across, and it would be like a light week across. It'd be about this, a little bit larger than our own solar system. To put it another way, if the entire galaxy was the size of the United States, like the continental United States, our solar system would be about the size of a penny.
Wow.
And so this supermassive black hole is about the size of a penny. So you paint the penny black and you throw it into the middle of a field in Kansas, and that's basically the supernova, or sorry, the black hole. But because we have a big old camera on the telescope, I actually want to try to show you. That is too low. What about you?
So while you're looking for the next item,
Yes.
just calling some shout outs. We have people from Germany on the
Oh.
call, or on my stream, UK, some of my friends from work, and obviously my riding trainer. He's
Well,
not
that's
chatting.
awesome.
He's not chatting on my stream, but sending me text messages. So there was a lot of interest in seeing the petroglyphs. So interesting. Oh, Florida. Wonder who's the Florida person. I think I know you, but I would say Slack me instead.
it's probably Eris.
Possibly.
Okay, so we're going to go to a galaxy named UGC 3457. I have never seen this galaxy before because it looks like a very boring, unremarkable galaxy in and of itself.
Let's go.
What? Say again?
Let's go.
Let's go. Let's do it.
Yes.
Well, the reason that I want to show you it is because right now there is a supernova in it.
Oh, okay.
And we're going to need to do probably a pretty decent exposure. So there is a 16th magnitude supernova in it. It was discovered. No. Okay, it was discovered today.
Look at that.
Yeah, it was discovered today by Lick Observatory Supernova Search. It's called 2022 BLM. And so the letters, it starts with 2022 A, B, C, D, all the way through the alphabet, and then you add another letter, and then you add another letter. So we've already found several hundred supernovas as of this year. Several hundred? Yeah, that sounds about right.
So I can read off one comment. I would ask to see Krypton, but I think Zod destroyed it.
Yes. Also, same as Alderaan. I can't show you Alderaan.
No, unfortunately.
What about Tatooine?
We actually have an equivalent of Tatooine. It's one of the exoplanets. It was discovered by the Kepler mission, but it is a little planet, a little bit larger than our Earth, that is orbiting 2 stars. So we
Nice.
found the equivalent. All right, so this little smudge right here, everybody see the little smudge? And let me zoom in even more. That smudge is a galaxy. And that little smudge right there, that is not a star within our galaxy, like every other one of these dots in this image. That is a supernova in this galaxy, right on the very outskirts of the galaxy.
Wow.
It's an overachiever.
When a star goes supernova, it will literally outshine its galaxy for the first 2 or 3 months. They're that energetic.
Wow.
If I can,
So we would anticipate then, as this one kind of loads out, that it would appear more like the previous one that we just looked at.
if we were within this galaxy, yes, absolutely.
Okay.
The problem is, and I'm trying to bring up, because I don't know this galaxy on my own very quickly, I am looking up, oh my God, it's such a uninteresting galaxy that we don't even have a distance calculation. We just have a redshift value.
So explain what that means for some of the people who don't look at the stars quite as often.
Yes, so our universe is expanding. And that's because it all started basically in the Big Bang. We can't say what happened before that, if there was before, but the whole universe is expanding outwards. And so besides a few very, very close galaxies to the Milky Way that are gravitationally interacting, like the Andromeda Galaxy or the Triangulum Galaxy, every other galaxy is actually moving away from us because the whole universe is still getting bigger. And because it's getting bigger roughly uniformly, galaxies that are further away from us now are moving away from us faster. You can think of it as like if you take a balloon and you put 3 dots on it and you blow the balloon up, the 2 dots away from you will get farther away from you, and the one that's farther will actually be moving away from you faster than the closer one. And I don't know if that actually did a good job explaining that.
It does. It's kind of similar to like the Doppler effect, or we do a red and blue shift when we're calculating for the locations. So you're just saying that it's really just the red wavelengths that you have the idea of how it deforms.
Yes, so because they're moving away from us faster, they are more redshifted.
Okay.
And so by getting the redshift, you can then determine its distance, because it's actually a very uniform number.
I just got an interesting question in chat. So, are there any alternative theories to the Big Bang Theory?
Not really. Back when the Big Bang Theory was first being thought about, there was a couple other ideas. In fact, the name The Big Bang Theory was from one of its opponents. There's a different group who basically thought that the universe, you could explain all the evidence for the Big Bang Theory with the idea that on the edges of our galaxy, or sorry, on the edges of our universe, material was just spontaneously forming. And there was tiny little bits of evidence for it at the time, but as our research got better and better and our error bars got smaller, that theory basically lost all merits, didn't fit the data anymore, and the Big Bang and inflation has become pretty much the thing. That's the entire universe at one point, about 13.799 billion years ago, the entire observable universe was all in the same spot. Now, we don't know what caused it or what happened before it. We don't even know if the word before is a correct term. We don't know if time existed before the Big Bang. It'd be kind of like saying, what is north of the North Pole? It's like, it doesn't really make sense. I think if I calculated this correctly, this galaxy is about 127 million light years away from us.
Okay.
So that means that the light that we're looking at right here, including that supernova, it left during the dinosaurs.
Wow.
Like the T-Rex wasn't a thing yet because they were in the Cretaceous, and we're talking 127 million years ago. That's older.
It is, yes.
I Googled 127 million, and I'm just getting a lot of articles about a baby bird fossil, which sounds kind of fun.
Do you have anything on Planet X?
There is the possibility, the prediction, the idea that there may be a true Planet 9 orbiting even farther out in our solar system. I haven't heard any updates on the research trying to find this. There was a few evidences that seem to suggest that there could be an object of about, I think it was 5 to 15 times the mass of our Earth, somewhere way out in the solar system. We're talking it would take 10 or 15,000 years to orbit the sun, really, 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 really far. But I haven't heard anything in the last three or 4 years on if there's more evidence to say that it exists, or we're still just trying to look through the sky and find it. Because we know where it should be, kind of a band in the sky, and so they've been using telescopes to kind of very sequentially look through that swath of the sky and try to find it. But it's pretty much right at the limit. Its brightness would be right at the limit of some of our larger telescopes.
What's the possibility of it being like a tiny grapefruit-sized black hole?
Pretty darn low. That it would have to have somehow formed, which black holes basically only form when really ridiculously massive stars die. And so the black holes would be the masses of several suns. And if we had a black hole that size orbiting our sun wouldn't be orbiting us, we would be orbiting it.
Okay.
What about Hawking radiation? Is the universe old enough to have made like the very first black hole and it evaporated down to a size where it could just kind of loosely be connected to a system like our solar system and not really cause havoc?
Not that I know of, but I don't actually know the calculations for Hawking radiation very well. For everybody else who's now having their eyes slowly glaze over, in completely empty space, particles just kind of come in and out of existence. We call them virtual particles. Kind of a proton and an electron and a positron just kind of pop into existence and then hit each other and immediately annihilate each other and just disappear. Basically just a little net zero effect, and it's just happening all kind of in the background. But on the very edge of a black hole, kind of on that event horizon, if one of these pairs pops into existence right on the event horizon, one of them will actually escape and the other one will get sucked into the black hole. And we can think of that as the black hole basically evaporating because it's losing a little bit of mass because of these pairs that get separated and one goes into the black hole. And the calculation is based on the size of the black hole and its rotation, how massive it is. So I actually don't know if there's been enough time for a stellar-sized black hole to evaporate enough to be, grapefruit-sized or something. It'd be really cool, though. Thank you for coming to my TED Talk. All right, time to show you probably one of the best things. This is M42, which is the Great Orion Nebula.
Oh, nice.
And so we got this chunk of nebula right here, but that's only part of it.
So from a just kind of a spatial perspective, is that some of the stars of Orion's belt, or how is it positioned within the constellation or in that mapping area of Orion?
This is below the belt. So if you can think of Orion kind of standing there with his bow out to one side, his two shoulders, and then his waist, it's basically in his right front pocket would be where this is. It's called the sword sheath.
Okay.
So there's three little stars. So you got the belt, and then you got three stars just below it in a row. And the middle star in the sword sheath is this nebula.
Ah.
And,
So
yes.
I guess you could say we're taking shots below the belt at Orion.
Yes.
Okay.
And we looked at Uranus earlier, so, All right, there we go. So this is a 30-second exposure, and it fills the entire field of view.
Wow.
That is beautiful.
It really is.
And even as I make it dimmer and dimmer and dimmer, you can see all the way down into the core all this awesome detail. This is a stellar nursery. Stars are literally being born in this nebula right now, 1,400 years ago. And we go right over here, we can look at my favorite thing that I can't see visually, but with a camera we can. So right here in the center, we call that the trapezium. 4 bright stars kind of makes a little trapezoid. And those are some of the biggest, hottest stars that have been born in this nebula. And they're actually pushing the nebula away from them with their solar wind. And so if we come over here slightly to the side, and I make it way too bright in the center, if you look kind of from the trapezium directly out, do you see this star right here? If I zoom in a little bit more, do you see this kind of edge? That is a bow shock. So the dust and gas being pushed away from the stars in the very center are now hitting the solar wind of this smaller star and kind of going around it. Think of like when Apollo lander comes through the atmosphere and it has that huge fireball around it.
Right.
It's the exact same thing, only instead of going through an atmosphere, it's the star pushing against even stronger wind from another star or another of stars.
What's the distance between those?
That is a very good question. I actually don't quite know, but I do know that the distance across the nebula from kind of its largest area is about 12 light years.
Wow.
So that would be about 4 then, maybe a little less.
If we can kind of bump this up kind of like that. Yeah, these are definitely within, maybe a dozen light weeks. These are very close because they're all born in the same area of space. The next closest star to our own sun is about 4 light years away. While these stars, your sky would be so bright. You would have your star, and then you would have, maybe your moon, and then you'd have a few dozen stars in your night sky that would be like Venus brightness.
Okay.
It would be pretty insane.
Right. Well, actually, I'll ask that question, even though I know it's not something we can look at. But this morning when I walked out, is that Venus that's super, super bright right now?
Should be, yes, because Venus is not our evening star right now. It's our morning star. So
Okay.
that probably was Venus. Don't
I
quote
didn't
me.
pull, no, I didn't pull out my little star maps, but I was pretty certain it was Venus just based on what I've seen.
Mhm. Well, it is 11:02.
Wow.
We've got a little bit over time, and we actually started a little bit early as well. Any last questions, or might be able to point at one last thing if you convince me. But
I don't
other than
know.
that,
I think
we're
we've
gonna be
seen
done.
quite a bit. I want to thank you so much, but I'll ask if anyone else has any questions or in my chat. Any last thing we'd like to look at? Maybe we could, do you have a picture with the colorized version of the Orion Nebula?
Yes, absolutely. That's a great place to end on.
Perfect.
So again, we go to everybody's favorite website. All right, so we're going to do this one. This was through our 24-inch telescope.
Oh, wow.
And so the rotation is a little bit different, but if we zoom right there into the center, there's those four.
Okay.
And then
Yeah,
there's the bow shock right there.
so neat. Wow, so I'm getting some thank yous from chat. People really enjoyed this, so thank you.
You are very, very welcome.
All right, anyone else from our Zoom call? Any last questions? Another from chat. This has really been an amazing experience. Thank you so much for sharing this and being a part of this. So, four thank yous.
Yeah, you are very welcome. And if you want to see some of these objects in person, the Orion Nebula is absolutely amazing visually with your own eyes through the telescope. So
No,
go to.
I'm really going to consider that because I would love to be able to see that, especially from a photography standpoint. So I'll probably be in touch again.
Yeah, absolutely. And visit our website. You can book tickets both for your own virtual star party or to come up for one of our nightly sky night program.
Right.
I completely blanked on the name. I need more caffeine.
Oh, I know. I had to struggle to stay awake this late. This is not my optimal time of the day. So.
My day is just getting started. I have to take this telescope and start doing some remote astrophotography, actually.
Oh, fun. Another amazing thank you for me. Totally worth ripping up my biorhythm. Lots of things.
Oh, good. I'm glad.
All right.
Okay. Well, then.
Thank you very much. This is awesome.
You're very welcome.
With that for my stream, well, I'm going to log off the Zoom meeting. And I'll go to my intermission.
Thank you.
Waiting, so I'll wave to all you guys as well.
I'm waving, but you can't see it.
Right.
Goodbye.
Here's the meeting. Okay. I'll let that go ahead and update. So, thanks so much to everyone on the stream that joined. It was really nice being able to share this experience with you. Thanks to Pause Reset for getting up and not that it was a lot of effort, but moderating for me. I will have this posted on YouTube. So those of you who didn't disrupt your biorhythms will be able to go and watch the entire YouTube video. So I'm going to stream again tomorrow. Feel free to join. I really appreciated this. This was a lot of fun. I'm going to try to do more streams like this that are not always gaming. So bye, everybody. Have a good night or good morning.